Okay, so let's continue with question 3, quadratic function. So consider the function g of x equals to f x squared. So g of x equals to x squared. That's 3.2, right? 3.2.1. Let's answer the questions now. What transformation did the graph of f, uh, which is equals to this, undergo in order to obtain the graph of g, which is g of x equals to x squared? Okay, so what did we do? Cool. So we'll start off with the brackets, inside the brackets. So we shifted the graph to the left by 1 unit. So we shifted to the left by 1 unit. When we shift to the left, we add. Okay. And we shifted the graph upwards by 9 units. When we shift upwards, we add. So in the y-axis, when we shift in the positive direction of the y-axis, we add. Negative direction of the y-axis, we subtract. But in the x-axis, it's the opposite. When we shift the graph to the right, which is the positive direction of the x-axis, we subtract. And when we shift to the left, which is the negative direction of the x-axis, we actually add. Okay? So it was shifted what? Horizontally to the left by 1 unit, vertically up by 9 units. Remember, the shift is we're transforming this graph from f of x to g of x. Okay. 3.2.2. Restrict the graph of g such that the inverse of this graph is a function. Okay. So the graph of g, which is x squared, looks like this. This is the graph of g. Now, make if we get the inverse of this, right, it will look like, so we have our mirror line here, which is y equals to x, right? Let me redraw this. We have our mirror line somewhere here. No need to draw it perfectly clearly. Alright, so this will look like this, and then this one would look like this. Right? But we want to make this green thing a function, because if we use the vertical line test, we're able to cut the graph twice, and we should only cut the graph once for it to be, in order for it to be a function. So if we can remove this bottom part here and be left with the top part, then that will be a function. If we can remove the top part and be left with the bottom part, that will also be a function. So the solution, you can either say this, we can restrict it to this portion here, which is x is less or equals to 0, right? You could provide this as a solution, you get your full marks. Or you can provide this as the solution, x is greater or equals to 0, and then you get your full marks. All right, perfect. So remember, this restriction is applied to the original function to give us an inverse graph that is actually a function. This restriction is applied to what? The original function, g of x in black, not the green one. Okay? So, 3.2.3. Determine the inverse of g in the form y equals to this. Include all restrictions. Include all restrictions. Okay, so for this one, inverse, we swap x and y. And we do what? We take the square root. Perfect. So, for this one, the restriction is x is greater or equals to 0. You can go with that. Okay? So we're done. If you've got any questions or comments as to how to solve some of these questions, please share with us so that we can learn from each other, right?